one more aspect about all of this, that is the angle at which the object hits the ground, or in general way, what is the angle? Let me explain what it means. I threw an object. The object is over here. So it makes an angle, that is the vector, velocity vector over here. It makes an angle. The question is, what is the angle with respect to the horizontal? So if we call this as, say, theta or something, what is this angle is what we are trying to look at. And when it hits the ground, say B, this is point P for me, what is the angle? Okay, so how can we resolve this? Actually, I gave the answer. We know Vx, we know Vy. So with the help of that, we'll be able to figure it out. So tan theta is given by opposite by adjacent. So opposite in this case is your, opposite would be your vertical component and adjacent is your horizontal component, correct? So we know the expression for Vy. Vy is G into T. And Ux is constant. So that is V U naught X or something I have taken. I forgot. U of X, correct. This is U of X. As simple as that. This is in general. At B, what happens? One specific thing changes over there. What is it? What changes over there? G does not change. T, yes, it becomes capital T. U of X remains the same. So at B, that is when it hits the ground, the time of flight will be T, and so on and so forth. So this is the point wherein it hits the ground. Again, all this is not to be remembered per se. It has to be derived every time, honestly. But of course, for competitive exam, you guys have to remember this. Technically, you should not be, right? This is on the ground. The point is on the ground. So the angle made by the object when it hits the ground is given by this. This is in general. Okay, guys. So these are all aspects that we'll see in pretty much everything. It can be horizontal component. It can be north and south component, east and west component. There are many things that we'll discuss, but this is the funda. Any given projectile motion or any given motion in this chapter or anywhere in the future, actually, even in 12th grade, all we're looking at is trajectory motion. We're looking at the velocity. Before that, we look at the force acting. We look at the acceleration, and then we look at the velocity. And then we'll move on to x and y axis. That's the flow. Here we have a small force. I mean, it's a huge force, but point is we are not taking it very seriously. Acceleration due to gravity, that is. Of course, it plays a role, but we're not discussing a lot about it because it is constant and stuff like that. So we are just taking it casually and we are substituting in the same equation of motion, but part by part, right? Along the x-axis, along the y-axis, so on and so forth. Then we expressed velocity in terms of, or we took the help of velocity to get an expression for x and y. Okay, so we ended up with x being u of x into t and y being half of gt square. So this two will give us what is happening with the particle at given moment of time. And we went on to look at the shape of the path and we found that it's parabolic. Time of flight depends on the height and acceleration due to gravity. And the range obviously depends on the height, acceleration due to gravity, and with what force are we throwing along the horizontal, that is. So that is nothing but your u of x, the initial velocity. Angle of impact is a simple geometric tan and stuff. So opposite by adjacent and so on and so forth. Okay, again, many things can be derived from all of this. So don't try to memorize everything. Derive every time, understand every time, and the formula will become second nature. Then you can memorize. Don't try to memorize at one go is what I'm trying to tell. You need to memorize, yes, but that should become second nature the first thing that you need to do for all of this, any kind of formula remembrance, is understand how we got the formula.